Okay, this is chapter 7.7. We're going to kind of review systems of inequalities and linear programming. And a lot of we're doing this because a lot of mathematical real life situations have to do with inequalities. You're using a machine where or something you can only use so many hours a day. You have to produce at least so many, like in this example, 500 cases of a certain product to meet a contract, to meet a deadline. Um, and mathematically speaking, when we do this, we get we create a line. We create a linear function that creates a line, right? That's what linear functions do. And a line divides a plane into three sets of points. The points that are above the line, represented by the lighter P. The darker side here is below the line, and then there's all the points that are on the line. So three different points. A linear equality in two variables can take this form, some coefficient times x plus b times y greater than, less than c. This inequality can be any inequality we want. And then what we get is which side of the plane we're looking at, and if it includes the line or not. So this one, if we solve this one for y, it would be everything above the line and including the line because it's got that little equals or equal to it below it. Okay, so we want to graph an inequality. We have to solve, get y by itself. So we work the algebra on this. Subtract x, divide by 4. You get this equation, y is greater than 1/4 x plus 1. So you graph that and you get this line. The blue line is the line. And if it does not include the line, we usually indicate that with a broken line that indicates that this is not, those points on that line are not included in the solution, only the points above that. We would shade the points above that to indicate that's our solution. It can be any of these numbers above the line on an inequality, right? Inequality can have any number of solutions. We just have to kind of figure out where that solution is going to be. Okay, so the example they give here is the graph a solution where you have a linear equation and a little parabola here, and they write it in terms of x is greater than 6 minus 2y, and x squared is less than 2y. Okay, so we need to solve this for y, and they kind of do this down here, but I want to show you a different way to do this. I'm also going to show you an easier way to do this on your calculator to get this shading to look better than it does with this one, and an easier way to do the shading. Okay, so I'm going to get out of this and go here. Okay, so these are our two equations, right? We've got um, x is is greater than 6 minus 2y. All right, so we want to solve for y. So I'm going to write x is minus 6 is, now I'm going to still keep that inequality the same, and I'm going to put negative 2y. Okay, so then to continue with that solution, what I need to do is divide by, the reason I'm doing this over here is so you can see what happened here. When you divide by a negative or multiply by a negative in your solution, you have to switch this inequality sign around. So the next step would look like this. We would have x minus 6 divided by negative 2, and then we have to switch that inequality around. So I'm going to just change colors to emphasize that. So the inequality would be going this way, and y would be over here. Okay, so if I rewrite that, it would be put to switch the y, and we're still going to have the the inequality going, the pointing away from the y. So if we switch it one side to the other, and I'm going to take this negative out of the bottom and put it on the top, so it looks a little different here. I'm going to put it 6 minus x over 2. And that's the way they had it in the book, but they didn't show you this inequality here, which way the inequality was going. Okay, the second one is a lot easier. We just divide by 2, x squared divided by 2, and that's still less than y. If we switch it around, we get y to look like this. Y is greater than, because the inequality is still pointing away from the y, x squared over 2. Okay, so this is going to be my y1 equation. This is going to be my y2 equation that I put in my calculator. All right, so I'm going to get my calculator going here, and I'll put this in the calculator. Okay, so y1 equals, I need to put this in parens, x, 6 minus x, and then I'm going to divide by 2. And then down here I'm going to put x squared divided by 2. Okay, so far so good. Okay, but what about the inequalities here? What about how do I get those in? Well, if you on the apps menu here, you hit the apps key and go down here until you scroll down till you find one called inequalities. Okay, so hit that one. Okay, it does its thing. Okay, so now we've got these interesting keys down here. When we hit the Y equals menu, we've got these keys show up down here. The equals, the less than or equal to, the greater than or equal to. And see how it's flashing on that equal sign? That's the way it starts. So to get that entered in here and to get the shading the way we want it, you have to use the alpha key and the right under whichever one of these things you want. You have these 5, they're called soft keys here, and they have this green F1 through F5, and you use those using the alpha key. So it's just kind of like the keyboard on the computer, but we want to use the green keys, we use the green alpha. So alpha trace puts that as a greater than. We want to do the same thing here. Alpha trace. Oh, I hit trace, right? Okay, there we go. Okay, hit the graph. Okay, so it does the shading there on the first one. Now it's going to do the parabola. Okay, so it's got this. This is kind of how it looks on the page in the book. But I want to make it a little better. So I hit the alpha, and then it doesn't matter either one of these buttons. Hit that one, and then I want to see which shades I want to do it. I'm just interested in the inequalities intersection, where the two inequalities. That's mostly what we're interested in on this one. So I do that, it redraws it. Okay, so it goes there. That's the shading for the first inequality. And then as the second one goes through, it erases the shading everywhere except where those two intersect. Okay, so that's the shading we're most interested in when we're doing these inequalities or two inequalities, where this is the solution area where it's shaded. And the point of interest on the trace, it kind of gives these intersections of the two lines here, y1 and y2, meet at x2, y2. So sometimes that you want to find that intersection, so that's a quick way to do that. So remember that the app is called, I'll reach down again, Inequalities. It depends on where it is in your app menu, but that's the one to run if you want to graph the inequalities with the right shading, right? So it looks like this, and it's very more useful than and easier to use than other ways of shading the graphs, okay? So get rid of that, get rid of this, go back to the slideshow. Okay, so they do that. They just show and they just graph in the first one, they graph the second one, they graph the boundaries, and they all had it nicely colored together. And we can find these 2 points of intersection if we want to, depending on what the problem is. Okay, so the other thing we do is called linear programming, where you have some constraints on different things. You have a minimum cost and a profit, maximum profit, something like that, all with different constraints. And they give an example here with VCRs. You guys might remember VCRs from your history class. Just think of them as VDIs, right? Or DVIs. Or what's the initials? Digital video DVRs, okay. DVRs. I'll get it. And so DVRs instead of a VCR, digital video recorder, right? Okay, so, and DVD players. We still have those, but they're getting obsolete too. So they have all these constraints. You have to have a $30 profit on one of them, a $70 profit on the other one. They make 10 of one, but no more than 50. They can't make more than 60 of the other ones, even though they could, you'd want to maximize that because they make the most profit on in the way this problem is on the DVDs. If they didn't have to make VCRs, they wouldn't, right? So we want to minimize this, maximize that. And then the number of VCRs can't exceed the DVD player. So all these, how much should they make of each one to satisfy these constraints and demands and get the most profit? Okay, so what you have to do is do the VCRs are the X value, so it has to be at least 10, but no more than 50. You can't make more than 60 of the DVRs, so it has to be less than 60. The VCRs have to be less than or equal to the DVD players, and you have to make some. It can't be, you have to be more than 0. Okay, so these are all our constraints. And if we graph all these constraints, the X's are just the vertical lines, the Y's are horizontal lines, and the X equals Y would be a one-to-one line. You get a polynomial kind of thing that looks like this. So you get all these graphs that kind of go together like that. That's the region of feasible solutions. And you're mostly interested in these points at each end of this feasible region. Okay. Um, then maximize the objective function. The 30x, that's the profit. We want the most profit. Make $30 every time we sell a VCR and $70 every time we sell a DVD. Okay, so most of the time that is going to be at one of these corners, almost all the time. And so what we do is you just check for the values, plug in these values at the corners and see which one is going to be um, give you the most of whatever function. Maybe you want to minimize something. It could be one of the other lower corners, or in this case for maximizing profits, so it's going to be up here at the upper right. Okay, so we make 50 VCRs and 60 DVDs. Okay, that gives us the most profit given the constraints we had with this system. So it's a little extra thinking on these things, but it's really not too hard, especially when you graph these and you look at the corners as solutions. Okay, so these are the steps to follow it. Write the objectives down, graph the feasibility reaching, identify all the vertices or the corner points, and then use those corner points as the values of your objective function, the one you're trying to maximize or minimize or whatever the problem wants you to do. So you're looking at the solution is going to be in one of those corners. And we're going through another example here, but I'll just stop it there and we'll talk about that, the rest of them in class tomorrow. So answer the questions on the forum.